This video is presented for the course Traitement des minéraux or Mineral Processing course, GCH8104 at Polytechnic Montreal for autumn 2020. When we talk about mineral processing, it is always good to know something a bit broader, extraction metallurgy. So let's see what is extraction metallurgy and have a very brief idea about it, and then we will see how mineral processing is positioned through extraction metallurgy context. Imagine that we would like to produce metals. So we know that the primary sources of metals are rocks in a mine. In this context, we are talking about some very important key words: rock, ore, mineral, and metal. Ore is produced from rock through ore extraction processes. Minerals are produced from ore through mineral extraction processes, and metals are produced from mineral through metal extraction processes. So, in other words, we have three different steps from conversion of the rock to metal: ore extraction, mineral extraction, and metal extraction. If you are asking about more details, what is ore, what is mineral, what is metal, so please be patient, we will see what they are exactly. In fact, in industry, uh, production of ore from rock is through a processing that is called mining, and mineral processing is about production of minerals from ore, and after having minerals of interest, we apply pyro and hydrometallurgical processes to produce metal. In general, conversion of ore to metal is called extraction metallurgy. Therefore, when we talk about extraction metallurgy, it is composed of two steps of mineral processing: pyrometallurgy and hydrometallurgy. So, in other words, when we talk about mineral processing, we mean production of mineral from ore. Okay, let's be a bit more focused on mining, the first upstream processing in production of metal, for example. As we said, ore is produced from rock. So when ore is produced from rock, of course, there are some streams that are not of our interest, and we call it waste rock. That's the stream that we don't like it. Similar thing is there for mineral processing. We produce valuable minerals from ore. Of course, there are some minerals that are not our interest, and we call that stream waste mineral. In other words, in mineral processing, we are trying to separate desired minerals from undesired minerals. That's the main objective in mineral processing. For example, let's imagine copper mineral bearing ore, which is chalcopyrite, CuFeS2, in an ore that contains also silica or quartz, SiO2. If we would like to produce copper, what we have to do is to first separate chalcopyrite from quartz through mineral processing. So therefore, We apply some special processing through mineral processing. We will have CuFeS2 in our design stream and SiO2 in our undesign stream. Of course, we will see in the next steps of mineral processing course where what are those mineral processing unit operations and the fact that are we going to completely separate charcoal prep from quartz or no, efficiency is not always 100%. We will see later. Now we would like to understand more basics of mineral processing and some important keywords in this context. So as we said, again, as a reminder, extraction metallurgy is about conversion of ore to mineral of interest through mineral processing, and then uh, applying pyro and hydrometallurgical processings to mineral of interest to produce metal. Okay, so now let's see, for example, what is hydrometallurgy, which is for metal production. Hydrometallurgy is in fact usually a wet processing approach in order to dissolve our mineral, which is of course in solid form, into a solution form. For example, imagine copper bearing mineral in the form of CuO. If you would like to uh, separate CuO from other solids that are accompanying CuO, we dissolve it into sulfuric acid. So we will have CuSO4 in solution, whereas other solids that used to be with CuO still remain in solid form. So this is a way of separating solids from each other by leaching process. Leaching is one of the steps, one of the very important unit operations and techniques in hydrometallurgy. Of course, there are some other methods in hydrometallurgy we will see later. But for example, now imagine that CuSO4 that we um, got into solution in the enriching step is used to now separate copper in pure form. Here in another unit operation in hydrometallurgy is electrolysis. In electrolysis, as you see, a cation of copper has affinity toward cathode of the in the electrolysis, while sulfate has affinity toward anode. So by a good design of electrolysis, we can have copper, uh, pure copper, collected around cathode, and later copper will be recovered. But what is pyrometallurgy? Pyrometallurgy is in fact a high temperature processing in order to decompose minerals, and it's another way to produce the metal. For example, consider smelting of iron oxide, which is reactive with carbon. So here, as you see, iron oxide reacts with carbon, which is a reducing uh, agent, in order to produce iron metal, of course, and as a consequence, we will produce CO2. As you see, temperature for this processing is about 1500 Celsius. So I have one question for you. What do you think we have to use as a reducing agent or whatever agent to produce copper from copper sulfate. In other words, pyrometallurgy is about using reactions at elevated temperature to break chemical bonds. So, as a reminder, hydrometallurgy was about uh, conversion of minerals which are produced after mineral processing step in low temperatures in wet mode to produce metals eventually. However, pyrometallurgy is not a wet process. It is high temperature, or sometimes we call it dry processing, by breaking the chemical bonds and producing uh, the metal of interest. In the case of iron, we talk about smelting, but some other pyrometallurgical techniques are there. For example, calcination. So back to mineral processing. When we are in the context of mineral processing, there are some keywords that are important to really know what they are about. For example, rock, deposit, and ore. If I ask you what is a rock, of course everybody has an idea, a general idea that rock is a big chunk of stone. But what exactly is rock? So what is a deposit? What is ore? Can we say ore is also a kind of big stone, or ore is a kind of powder? But there are some more um, uh, kind of technical terms to really identify what is a rock, what is a deposit, and what is an ore. Rock, in fact, is an assemblage of minerals. So, in other words, minerals, several minerals are together and they form a rock. But if the rock contains a valuable mineral, it is then called a deposit. For example, if you have a stone that has some gold inside, okay, that rock is then a deposit because it's a very, very valuable mineral. On the other hand, not all the deposits that have valuable minerals can be called like ore, okay? In other words, if the mineral can be extracted at a profit, it becomes an ore. Just to give you an example, these days there are a lot of efforts to produce the rare earth elements, which are some metals extremely critical for clean technologies. However, the rare earth elements are called rare not because they are not abundant on Earth. There are a lot of rare earth deposits. The problem is extraction of rare earth is not always profitable, is not economic. So we cannot call all deposits of rare earth ore. There are very few deposits from which extraction of the rare earth elements is viable. So there are few deposits where we can produce ore. Okay, imagine this picture. For example, here you have a big this kind of um, stone, what you can say, or rock, but you can see some yellow colors. These yellow colors are about some presence of some valuable metal. So these are obtained by exploration. By doing some more work, uh, by in some economy analysis and by cost of extraction, if we figure out that extraction of these yellow parts, which are in fact copper, is economically viable, then we can call it ore of copper or copper ore. Just to give you a broad image, when we talk about mine, see we have usually this kind of shapes in a mine that are related to exploration processing. And this picture that you see here is just a very small piece in a mine. So to remind you again, when we talk about mining, we would like to produce ore eventually from rock. As we just realized, ore is that part of the rock that is economically viable for extraction. Again, look at this picture of copper deposit. As you see, uh, the proportion of these yellow colors with respect to this kind of gray proportion is uh, much smaller. Maybe at least based on the color on the surface, you can tell it is like maybe 10% of the mineral. Okay, I'm not sure right now, but at least by image you can say that. In mineral processing, usually that part of the ore that is not interesting, we call it gangue. So by in mineral processing, we are going to remove this part of the ore from the valuable part of the ore or the valuable minerals uh, by different unit operations and get rid of this part that is called gangue. So to be more clear, in mineral processing, we would like to produce valuable minerals and reject the waste mineral that is called gangue. So if somebody talks about gangue in mineral processing, we should always know that the gangue is the portion of the ore that is not desired. Of course, if you imagine process valorization, there's a lot of efforts in order to even use the gang for some value added for the purposes. But when we say gang, it means it is a gang or it is the undesired portion of the ore compared to the valuable part of the ore or valuable minerals. To be more specific about desired minerals and the gangs, uh, in mineral processing, when the ore is converted to a mineral, in fact, we say that part of that desired part of the production, which is about desired mineral, is called a concentrate, and that portion that is a gangue portion is separated and it is called tailings. So when in mineral processing, when we talk about tailings, we mean that portion of the ore that was separated and it is not our um, desired part of the ore. However, the tailing is not only that undesired portion. Tailing is also about some other chemicals and additives that were used in the course of the mineral processing and now they are rejected. So what have we learned so far? Mineral processing takes place at the mine site on surface. Okay. The mineral processing plant is called a concentrator or a mill. The concentrator takes its name from the major commodities in the world. For example, if we would like to produce a concentrate of copper, we call it we call that mineral processing unit copper concentrator. Or if it is about lead and zinc, we call it PBZN, for example, concentrator. Therefore, the valuable mineral product that we are going to produce from mineral processing is called a concentrate. And the gang product is the tailings. Just to remind you again, uh, we in mineral processing, we have gang and we have valuable minerals. And we would like to produce a concentrate of the valuable minerals after there's its separation, there is or their separation from the gang. But there are a lot of challenges in order to do so. To in order to produce a concentrate of the valuable mineral, extraction of the mineral has to be done in several stages. Those stages are usually in general from size reduction, separation, which are mostly physical separations, like magnetic separation, gravity separation, electrostatic precipitation, and froth flotation, dewatering, because especially, for example, after froth flotation, uh, we have wet products, so we have to do dewatering, and at the end, product handling. These four steps are the big uh, and high-level steps in mineral processing. And in this course, we are going to cover up each stage and see what they are. So eventually you will have a very good idea and a clear insight into mineral processing, and you will see uh, and you are going to discover many things, I'm sure, that you never imagined before, and you will see then how mineral processing is important these days.